This is page 52 in your math journal. We're going to call it factoring and prime numbers. Alright, I think you guys have learned this before, but I feel it's a very valuable review. Put a star right here. We're going to put a definition of prime numbers. Prime numbers are the building blocks of all the other numbers. They're the numbers that are divisible by 1 and themselves. So let's write divisible by 1 and itself. So let's list the first few that we can think of. So let's just start counting. One's a special one. It is divisible by 1 and itself, but what's itself? So it only has itself as a factor, so it technically does not count. But 1 will go into every other number. So we're going to start with the first prime number, which is 2. 2 is divisible by 1 and 2. 3 is also a prime number. What do you think about 4? 4 can be divided by 4, 2, or 1. So 4 is what we call a composite number. Okay, I'm going to put a star right here. We're going to start composite numbers. We'll come back to this line, so don't do anything with it yet. Okay, a composite number is divisible by 3 or more factors. So think about the number 4. Remember, it was divisible by 1, 2, and 4. It's a composite number. So we can write that as an example. There are more composite numbers than there are prime numbers. So 4 is divisible by 1, 2, and 4. Okay, let's come back up here to the prime numbers. 4 doesn't work. What about 5? 5 can only be divided by 1 and itself. 6. Now here's the clue. 2 is the only even prime number, because think about it. Any number after 2 can be divided by 2 plus itself, plus 1. So any even numbers from here on out, we're not even going to have to worry about. So let's just look at the odds. 7 is divisible only by 1 in itself. 9. If that caught you, 9 is divisible by 1, 3, and 9. Okay, next one, 11. 11 is a prime number, so is 13. 15, what do you think? Nope, that one's divisible by 5 as well as 1 in itself, and 3, so it would be a composite number. Next one, 17. 17 is. 19 is also a prime number. 21. Nope. 3 times 7 would get me 21, so that one's a composite. 23. 25 is divisible by 5, so that one's not. 27 is divisible by 9. 29 would be. Okay, 31. And they keep going, but those are going to be the most common ones you're going to come across and use. Alright, let's go to the next definition I want you to write. Okay, factors. Okay, factors are numbers that divide evenly into another number. Also, remember that factors are also parts of a multiplication problem, but that would make sense. Like 3 times 5 gives you 15. Well, 15 is divisible by 3 and by 5. So I'm going to write parts of multiplication here also. All right, so we're going to practice factoring numbers. So we're going to list all the factors of some numbers. So how about we do, let's try 16. List all the factors I'm going to write of each number because we're going to do a few numbers here. So list all the factors of each number. Okay, I'm going to skip a line just for space. I'm going to write 16 here. Okay, I'm going to teach you what they call the factor rainbow. All it is a way to help you mentally make sure you're not skipping anything. So the first one to always start with is the lowest number that will divide into the number. Well, what number divides into every other number? 1. Now, the rainbow part is, this is the very outside edge of this rainbow. We're going to go to the very outside edge, or the biggest number that will divide into it, basically 1's partner. 1 times what gives you 16? Okay, and I leave space because you don't know how many factors you're going to get. So we want to write 16 out here. It's okay if we have more space in between, but that way I don't start clumping my numbers together if I run out of space. So 1 and 16 go together. So there you can see part of my rainbow. Okay, then I start counting up 2. Will 2 go into 16? Yes, it will. So I'm going to write 2. And what's on the other end of the rainbow for it? 2 times 8. How about 3? 3 won't go evenly into 16. So move on to the next one. 4. 4 will go into 16. So I'm going to write 4. And what's its partner? Well, 4 times 4, so it's going to come back to itself. But since I've met the other side of the rainbow, I know that 5, 6, 7, or 8 won't fit in between there. So 1, 2, 4, 8, and 16 are all the factors of 16. Okay, skip a line. Let's do another one. Let's try 48. So if I put 48 here, always start with 1. Okay, leave space because you don't want to be shoving numbers in here. See how I had extra space? That's not a big deal. But if I run out of space, then I'm trying to fit them all in there, and remember, it's just easier to have more space. So 1 times 48 will give me 48. I'm going to write 48 over here so I have enough space. And the bigger the number, the more space you want to leave because there is a better chance of more factors going into it. Okay, 2 will go into 48. 2 times what? If you're not sure, do 48 divided by 2. But why do I know that 2 will go into it? Well, 48 is an even number, so 2 has to go into 48. 48 is 2 times 24. Now see how I've skipped from 48 to 24? That tells me that there are no numbers between 24 and 48 that will possibly work. I haven't skipped anything here. But this helps me so that I'm not missing anything. Will 3 go into 48? It will. If you're not sure, you can always divide on the side. 3 goes into 48 16 times. Will 4 go into 48? Yes, it will. 4 times 12. Will 5 go into 48? Notice I haven't skipped any numbers here so far. 5 will not go into 48, so I go to the next number, 6. 6 will go into 48. 6 times 8 gives me 48. Okay, will 7 go into 48? No, so 8, I have already written 8. I've met the other end of my rainbow, if you want to think of it that way. Now I know that I have listed all the factors of 48. But see how many factors there are here? If I would have written 1 and 48 like right here, I wouldn't have had room. So make sure you give yourself some space when you're doing this kind of method. Alright, another little definition. Okay, prime factorization. So what we just did was we listed all factors of the numbers. Prime factorization is finding every prime number I call it the recipe of a number because each number has a specific, every composite number I should say, well actually prime too, but has a specific amount of prime numbers in certain combinations to make that number. And it doesn't matter how you break it down, it will always break down into those prime building blocks. So we're finding the recipe basically to find that make up a composite number, okay? So that make a composite. And just because I'm running out of space, I'm going to write the number sign for a number, okay? So, we listed all the factors of 16 up here, but if I want to find the prime building blocks of 16, I'm going to break it down. And I want to show you that it doesn't matter how you break it down. We're going to actually do it two different ways and see that you get the same exact prime building blocks when you're done. So, looking at 16, I just need to think of two things that multiply to get me 16. I know some of your heads are instantly jumping to 2 and 8, which is fine. Now, if you have a prime number, you circle it. That's the end of that branch of this factor tree. 8 breaks down more. 8 breaks down into 4 times 2. 2 is prime. I break down 4 and I get 2 and 2. Now, every single branch of that tree is ended in a prime number. So, what if I decided I wanted to do 1 and 16? Does that help me? No. Since 1 isn't prime, we don't bother doing it. And then we're stuck with the same number. So, we want to think of two numbers that multiply to get 16 that aren't 1 in itself. So, another way we could have gotten 16 would be 4 times 4. Okay, break down 4 and 4. That gives me 2 times 2. Those are prime. Break down 4 here. It gives me 2 times 2. So no matter which way I decided to break down 16, 16 is made up of 2 times 2 times 2 times 2. That's the prime factorization of 16. Okay, let's try a little bit bigger number. How about we go with 42? Okay, there's many ways to start breaking it down. As long as it's two factors that go into that number, it does not matter. Okay, the first ones that come to mind for me for 42 are 6 and 7. So I'm going to write 6 and 7. Now I know that 7 is prime, so I'm going to break down 6. 6 breaks down into 2 times 3. Every branch of that tree ends in a prime number. So 42's prime factorization is 2 times 3 times 7. Okay, what about something that's maybe not as familiar? How about, like, let's say 156. Okay, before you start thinking that you can't do it, look at the number. There's a couple of tricks we can use. First of all, if it's an even number, I know that 2 has to go into it. So if I don't know where else to start, I'm just going to start with 2. That and dividing by 2 is easy. So I know 2 is going to go into it. Now I'm going to do 156 divided by 2 to figure out what I get here. Okay, if I do that, I would get 78. If you're not sure, do 156 in the box, divide by 2, and figure it out. Break down 78. Once again, it's an unfamiliar number. It's not one of the normal multiplication numbers I've memorized, so I know it's even, so I know that 2 will go into it. Okay, if I divide 78 by 2, I get 39. 39 might be prime, but I can do a few other tests. It's not even, so 2 won't go into it anymore. But 3 plus 9 is 12. If I can add the digits together, and 3 will go into that number, I know 3 will go into the whole number. So since 3 will go into 12, I know 3 will go into this. So I'm going to break it down 3, and sometimes you just have to test it, but you know the prime numbers to work with. You might try 7 or 11, and if it doesn't work, try another one. I know 3 will go into it. Well, when I divide 39 by 3, I get 13. So that's another prime number. I'm going to show you quickly, though, that 3 trick on 156. 1 plus 5 is 6, plus 6 is 12. So I could have known right off that 3 would have gone into 156. Same with this one. Look, 4 plus 2 is 6. Well, 3 goes into 42. Kind of a cool little trick. Anyway, the prime factorization of 156 would be 2 times 2 times 3 times 13. And when we do prime factorization, we try to list them least to greatest, but it doesn't matter, but it helps your brain stay a little more organized. So that's how we do it. So that's prime factoring. Make sure you write really nice, and see you tomorrow.